Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about the flow rate measuring device known as flow nozzles. Here we will study its basic principle, its construction, working, along with its advantages, disadvantages and applications. So let us start with our topic. So flow nozzles are a type of flow rate measuring device which measures the flow rate of the liquids and gases which are flowing in a pipe. So flow rate of both liquids and gases can be measured with the help of flow nozzles. Now flow nozzles, they come under the category or the class of devices which are known as obstruction meters. The other flow rate measuring devices like orifice plates, venturi meter, they are also a type of obstruction meter, and flow nozzle is also a type of an obstruction meter. It is called obstruction meter because when this device is placed in the pipe in which the fluid whose flow rate we want to measure is flowing, so in that pipe this flow nozzle will act as an obstruction or as an obstacle, and due to the presence of this obstacle there is a change in the pressure of the fluid. Okay, so we are going to measure the flow rate by measuring the changes in the pressure caused by the obstruction. So flow nozzle is an obstruction meter. It acts as an obstruction or as an obstacle in the path of the fluid, and due to this obstruction there is a change in the pressure, and this change in pressure is dependent on the flow rate of the liquid. Now this change in pressure is measured with the help of a differential pressure sensor. And the difference in pressure measured by this will be proportional to the flow rate of the fluid. Okay, if the rate of flow is very high, then there will be a very much pressure difference will be created. Okay, and if the flow rate is less, then less pressure difference will be created. So flow change in pressure is proportional to the flow rate of the liquid. So in the flow nozzles we are indirectly measuring the flow rate. So it is a type of an indirect method where the flow rate is measured by measuring the changes in the pressure. Okay. Now flow nozzles, they are the indirect methods, and also we can say that they are the mechanical means of measuring the flow rate. Mechanical means because only the construction of the flow nozzles is such that it is creating the pressure difference. No electrical method is used, only the mechanical parts or the construction of flow nozzle is such that it is used to measure the flow rate. Okay, so flow nozzles are a type of mechanical means for the flow rate measurement and the indirect method of flow rate measurement. So this was the basic principle of the flow nozzle, that when the flow nozzle is placed in the pipe in which the fluid is flowing, whose flow rate we want to measure. So due to the presence of the flow nozzle, there will be a pressure drop, or there will be a change in the pressure, and this change in pressure is measured by the differential pressure sensor, and change in pressure is proportional to the flow rate. So that was the basic principle. Now comes the construction of flow nozzle. Let us first see its diagram, so that with the help of diagram we will be able to see the various parts of the flow nozzle. And this is the entrance. You can see that from here the fluid is entering. After that it is having a converging section, and then it is the part which is called the throat, and from here the fluid is coming out of the flow nozzles. With the help of flanges, these are the flanges, there are flanges with the help of which it is being attached in the pipe in which the fluid is flowing. Now this inside diameter, diameter of this flow nozzle, that should be equal to the inside diameter of the pipe, so that flow nozzle get fixed inside the pipe, and the fluid is going to enter, all the fluid is going to enter the flow nozzle. So here you can see that there are two main parts. One is the converging section and one is the throat. So flow nozzle, it is held between the flanges of the pipe, and the pipe in which the fluid whose flow rate we want to measure is flowing. Okay, so with the help of flanges it is fixed inside the pipe. After that, in the flow nozzle, the area which is the part which is having the minimum area is called the throat. Okay, so throat is the part of the flow nozzle which is having the minimum area. Now there are two openings. One is the opening from where the fluid is entering, and another opening from which the fluid is coming out of the flow nozzles. Now the pressure which we want to measure when this fluid is flowing, due to this obstruction of flow nozzle, there will be a change in the pressure. So first we are going to measure the pressure at this point, that is the section 1, and after coming out of the flow nozzle, here also we are going to measure the pressure which is the section 2. So two measurements of pressure are done, one at the section 1 and other at the section 2. So here when this flow nozzle is kept in the pipe, so manometer, U-tube manometer is used to measure the pressure difference. So one tube is kept here because it is a U-tube manometer. So one opening is here and another opening is here. So from both these sections the pressure can be measured by the U-tube manometer. The difference in the pressure can be measured. So two openings are there where the U-tube manometer is used. So primary device is the flow nozzle which is creating the pressure difference, and secondary device is the U-tube manometer which is measuring the change in the pressure or difference in the pressure. So this was the construction of the flow nozzles, that showing various parts of it. It consists of the converging part. Okay, so due to the converging part there will be a change in the pressure, because when the fluid is flowing in a greater area its velocity is less but pressure will be high. But when it is passing through a very small area its velocity will be high but pressure will be minimum. So at section 1 we will have a high pressure reading, and at section 2 we will have a low pressure reading. Or we can say that due to this flow nozzle there is a pressure drop, okay, in the fluid. So this converging part is creating the change in the velocity of the fluid or change in the flow rate of the fluid, due to which the pressure drop is being created. Throat is the part which is having minimum area, okay, and with the help of flanges it is fit inside the pipe. Now let's see the working or the operation of flow nozzles. See its diagram. So when this flow nozzle, you can see that this is the pipe in which the fluid is flowing. So this arrow is showing the flow direction of flow of the fluid. So from this converging part, this fluid is entering, and from the throat it is coming out. Okay. Now this is the upstream, this is downstream. So when this fluid is flowing and entering this, so here the pressure will be different. That is called the pressure P1, and when it is coming out, the pressure will be, there will be a pressure drop. Okay, because the velocity is increased, and when velocity is increased, pressure is minimum. So here we will have a different pressure called P2. So this P1 pressure is measured by this differential pressure, means this is the differential pressure sensor. A U-tube manometer is there which is measuring the P1 and P2, and the difference in pressure can be measured with it. Okay. So here the velocity is minimum but pressure is maximum. Here velocity is maximum but pressure is minimum, and due to this converging part and the throat, because throat is having a very small area, so when a fluid is entering from a very small area, its velocity is increased. Now when you see this flow nozzles, the flow nozzle is just similar to the venturi tube. In venturi tubes we were having the converging part, throat, and a diverging part also, but in flow nozzles no diverging part is present, only converging part and the throat is present. So there will be a pressure drop, but in venturi tube, because of the presence of the diverging part, again the pressure can be recovered, but here no recovery of pressure is there. The pressure drop will be created due to the presence of the flow nozzles. So let's see it's working. So with the help of flow chart, we can understand it's working. Fluid is entering the flow nozzles. When the fluid is entering the nozzles, before entrance, the pressure is P1. Now when this fluid reaches the throat is the area which is, it is the part which is having the minimum area. So fluid is going to converge at that part, and due to which the pressure reduces. Now this pressure reduces until it reaches the minimum value, and this pressure is called the pressure P2. Okay, so after coming out of the flow nozzles, the pressure is P2, and before entering the flow nozzle, the pressure is P1. Now if a differential pressure sensor is connected between these 2 points 1 and 2, then that is going to measure the pressure difference P1 minus P2, and this pressure difference is an indication of the flow rate of the fluid flowing in the pipe. Okay, so this is the flow chart of the working of the flow nozzles. So we have seen here its construction and working, that how the flow nozzles, they are measuring the flow rate of the liquids and gases by measuring the change in the pressure, and this change in pressure is measured with the help of a differential pressure sensor. So this was all about the construction and working. Now comes its advantages and disadvantages. The first advantage is that its installation is easy. It's a very cheap device. compact, high coefficient of discharge, and less susceptible to wear and tear, or we can say damage. So its installation is very easy. With the help of flanges we can install it in the pipe, so no complexity is there. Also it is cheap and compact because of its low dimension as compared to the venturi tube, because venturi tube is very long in its length. It is having converging part, throat and the diverging part, whereas in the float it is just half of it only having the converging and the throat part. So it is a very compact device. Its length is less. Also it is having very high coefficient of discharge, and it is less susceptible to the wear and damages. Next come its disadvantages. No divergent outlet, and hence low pressure recovery. Because in the venturi tube we were having the diverging part, so this due to the presence of diverging part, the pressure drop is again recovered. In the venturi tube we have a converging part, then a throat is there, and then we are having a diverging part. Okay, so due to the converging part and throat the pressure is decreasing, but again due to the diverging part the pressure is increased. So here pressure is high, here pressure is decreased, but due to diverging part again pressure is recovered. But in flow nozzles we are having only the converging and the throat part is there. So when it is entering pressure is high, and after coming out the pressure is less. So no pressure recovery is there in the flow nozzle, so this is a disadvantage. Also after coming out there will be a pressure loss in the fluid. Okay, it cannot be used in low pressure head, because if pressure is low then after coming out the pressure will be further decreased. So it cannot be used in those conditions where there is a low pressure head. Now this flow nozzle, it cannot be used as a flow meter for the measurement of flow rate of those fluids in which they are having the solid particles, because these solid particles they can damage the flow nozzles. Also they can give the inaccurate results in the measurement. Also its maintenance is very high. And if its installation is compared with the orifice plates, then its installation is difficult. So compared to orifice plates, its installation is difficult, but if it is compared with the venturi meter, then its installation is very easy. So these are the disadvantage, or we can say limitations, of flow nozzles. Now come its applications. So it is used for the measurement of flow rate for liquids and gases. So it can measure the flow rate of the liquids which are discharged into the atmosphere. Also, it is used in the situations where the solid particles in the liquid, they have the property of settling down. Okay, because here in the disadvantage we have seen that it cannot be used for fluids having solid particles, but if these solid particles, they have the settling property that they are going to settle down, then it can be used to measure the flow rate of the suspended solid. Also, it is widely used for the high pressure and temperature steam flows. So not only the liquids but also the gases, their flow rate can be measured under high pressure and temperature conditions. So these are some of the applications of the flow nozzles. So here in this video, we studied about the flow rate measuring device known as flow nozzles. We studied here its basic principle, its construction, working, advantages, disadvantages, along with its applications. So I hope that this topic is now clear to you. Thank you.